Fabrication of transistors, diodes, resistors and capacitor. Transistor. A transistor may have a p-type, n-type, emitter, collector and base region. So, as shown in the diagram, a p-type substrate is first grown and then the collector, emitter and the base regions are diffused on the top of it. So, both the diodes and the transistors are manufactured by the process called epitaxial planar diffusion process. In this transistor fabrication, we have a problem where p-type substrate is considered as the collector in some of the discrete varieties. So, this may cause a problem. Hence, we use a separate collector regions. Though we use separate collector regions, they are not completely separated from the p-type substrate. So this may cause uneven or unwanted parasitic junctions when reverse biased. This can affect the circuit performance adversely. So for this, we may have to keep the p-type substrate in negative to that of the transistor collector. So other problem in transistor is the junction reverse leakage current. So this junction reverse leakage current affect the circuit high frequency performance and the junction breakdown voltage. Then if the substrate is very lightly loped, it will behave mostly as an insulator. Diodes. Fabrication of diodes. So as told earlier, the diodes are also manufactured by epitaxial planar diffusion process. Here we don't have so many layers as that of the transistor. We have only p-type and n-type junction. The collector base junction. Here the collector base junction of the transistor is used as a diode. Anode of the diode is formed during the base diffusion of the transistor and the collector region of the transistor becomes the cathode of the diode. So the diode process is simple. Let's go to the resistor. Resistors are mostly given ohmic value by varying the concentration of the doping impurity into it. The resistance may vary from several ohms to several hundred ohms of several hundred kilo ohms, and their tolerance may be usually plus or minus 5% to plus or minus 20%. Another diffusion technique used for the growth of IC resistors are a thin film technique. So in this process, a metal film is deposited on a glass or a SiO2 surface, and the resistance value can be controlled by varying thickness, width and length of the film. This is all about resistors. Now the capacitors. The capacitor may also have a P and N type regions where the dielectric of the capacitor is the depletion region between them. All the N type junctions have capacitance, so the capacitors may be produced by fabricating junctions. The capacitor, using the SiO2 as dielectric material, we may fabricate the capacitor. One plate of the capacitor is formed by a heavily doped N region. The other plate is formed by a film of aluminum on the silicon dioxide dielectric. So hence for such a capacitor, a voltage of any polarity can be used.